There's very little that gets me as excited as how quickly and easily you all have picked up the idea of Extrema. You talked about it last year with Mr. Pedanoff, but we're going to bump that up to the next level and talk about the fact that there can be multiple Extrema, which is the coolest question that you all have asked. It shows some really intense and strong thought process behind this whole thing. So, you've already been able to identify the Extrema on a graph like this. You would have pointed to this point right here and said, okay, that's a minimum, this is a maximum, and this is a minimum. That's incredible. Super thankful for that. Let's talk about how we can talk about them more concretely, more specifically. So this point is, in fact, a type of maximum. And let's go ahead and give it coordinates. Well, it looks like it's at 1, 2, comma, 1, 2, 3-ish. It's not a perfect answer. And then here we've got some type of minimum. Let's give that coordinates as well. 1, 2, 3, 4, 5. Looks like it's occurring at 5, comma, 1. My favorite question that a student asked me was, how do you know exactly where the maximum and minimum is? And the short answer for that is, you don't yet. You need calculus. So hang tight for next year. In the meantime, we're just kind of getting the idea of the shapes of them, and we want to make sure we can spot them and recognize them. Over here, this is also a type of minimum. And this one appears to be occurring at 1, 2, 3, 4, 5, negative 5, comma, 1, 2, 3. Oh, negative 3, come on. So then the question is, which one of those is the real minimum, and what language can we use to talk about it? You all have already come up with this, and you all know right away, intuitively, this is the minimum. This is not actually the minimum. But this is still, it is a low point in the graph. So the words that I'm going to give you are, this is our absolute or global minimum, and it means the very lowest point that exists for the entire function. And this is just a relative or a local minimum. It's not the lowest point, but it is a low point on the graph. This one right here, the maximum, think briefly about whether that's local or global, whether it's relative or absolute. So it is a high point, but look over here, there's a million points that are higher on either end. So in fact, this is going to be only a relative or a local maximum. Then this is what allows us, though, to create intervals of increase and decrease. This function is decreasing, 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 decreasing. When it hits the minimum, it is stationary. Then it's increasing until it hits the maximum. And then it's decreasing until it hits the minimum. And then it's increasing again until it hits the maximum. So, if we want to write intervals of increase and decrease, this function is increasing in two places, which is why I'm going to have two different intervals. The first place it's increasing is from this minimum to this maximum, just sort of in this range right here. So that goes from negative 5 all the way to positive 2. But there's another place where it's increasing, from this minimum all the way to the infinite far right side of the graph. So we're also going to say that it's increasing from 5 all the way up to positive infinity. This u implies that there are two separate intervals where this is true. One goes from negative 5 to 2, the other goes from 5 to infinity. Intervals of decrease are going to work in almost the exact same way. Again, there are two places where it's decreasing, one from here down to there, and another in this little tiny space from here to there. So that is going to be from negative infinity until it gets to negative 5. And then the other interval of decrease is going to go from this maximum down to that minimum. So that's from 2 to 5. And that's it. You use the x-coordinates to talk about the intervals. You use the full point, the coordinate point, to talk about the actual maximum and minima. But these intervals of increase and decrease, we just use the x-coordinates because that tells us where the behavior is occurring, even if we don't necessarily know how high up or high